Hello friends, this is MUKESH KONAI for Saptarshi Mindware EduTech. In our previous lecture, we discussed about different terminology related to spherical mirrors or convex and concave mirror. Now let's try to locate these terms on both concave mirror and convex mirror. Here, this point, the center of curvature is the center of the spherical mirror from where we have cut. This point is the focus and this is the pole. Okay, the distance, the length between the focus and the pole is called focal length. Okay, and radius of curvature, what is radius of curvature? So the distance between the pole and the center of curvature is called radius of curvature. Okay, so here I have located all this point, and if the mirror is a convex mirror, then this is our focal length, on the other side F, and this is our R from, so this is our R and this is the focus. Okay, so for concave mirror and convex mirror, if I have to show the aperture, then what is that aperture here? So I draw a dotted line. So this point, this length from let's say from this is P and Q. So PQ is the aperture. Here A is equal to PQ. Okay, and this is called the aperture. Okay. Now let's try to discuss how images are formed by the spherical mirrors, because they are mirrors. So definitely when rays of light will be incident on them, the images will be formed. So before we go for image formation by spherical mirrors, let's discuss what rules these rays of light when incident on these two mirrors will follow. Okay, so we'll first discuss, students, rules of ray diagram. Okay, rules of ray diagram. Okay, that is, if a ray of light is incident on the mirror, convex and concave mirror, then what will be their path? So first thing, I am going to write rules of ray diagram. Rules of ray diagram. So as we have two types of mirrors, spherical mirrors, convex and concave mirror. So here I write here first concave mirror, and here I write convex mirror. Okay, and write the rules one by one. So first I'll take one concave mirror over here. Okay, say this is the focus and this is the center of curvature, this is the pole, right? So a ray of light is incident parallel to the principal axis. Then after reflection it passes through the focus. Okay. Second here, so for convex mirror, similarly, convex mirror is externally curved mirror. So I draw one convex mirror externally curved, and then the principal axis, right? So principal axis of the mirror. So this is the pole and the focus is rotated on the right hand side. So F and center of curvature. Now I take one ray parallel to the principal axis. So according, this is a diverging mirror. So what will happen? It will diverge, and it will appear to diverge from the focus. Okay. So I want to show the angle of incidence and angle of reflection for this. So what I will do, I will draw one dotted line from the center of curvature. So this is the angle of incidence and this is the angle of reflection. I also want to draw so the angle of incidence and angle of reflection in this convex mirror. So what I will do, I will draw one dotted line from the center of curvature of the convex mirror. So this is angle I and this is angle R, right? So what is this first rule? A ray of light incident parallel to the principal axis of a concave mirror is reflected from the focus. Okay. Second, students, what if the ray of light is incident at the focus? If it passes through the focus, what will happen? Then here, so like I take here again the pole, the focus, and here the center of curvature. This line is passing through the focus. Light has a reversibility property. Okay, reversibility property is like the path. Reversibility is the path followed by the incident ray. If the position is interchanged, then the path of reflected ray will be path of the incident ray. So if the ray of light in first one, you might have seen that when the ray of light is incident parallelly, then it is passing through the focus. And if it passes through the focus, then what will happen? It will become parallel. This is reversibility. Okay. And what if I take here one convex mirror? So for convex mirror, I have to draw one convex mirror over here. Okay, convex mirror I have drawn. Now all the center of curvature and focus lies on the right hand side. So I take one here ray of light as if it appears to incident on the focus. Then what will happen? It will become parallel. It will be reflected parallel. Now to show the angle of incidence and angle of reflection, what I have to do? I have to draw one line passing through the center of curvature. So this is angle I and this is angle R, right? Similarly here also I draw here, I take one line from the center of curvature. So this is angle I and this is angle R. Third rule, what is the third rule? Now the ray of light, so again for the third rule, so for this, what is it? A ray of light, the rule is a ray of light which is incident such that it passes through the focus of a concave mirror after reflection becomes parallel. Okay. Now the third rule is this: what if it is incident at the pole? What if it is incident at the pole of the concave mirror? So if it is incident at the pole, then it will be reflected below the principal axis such that angle I is equal to angle R. Okay. And if it is a convex mirror, then what will happen? Same thing. If it is incident at the pole, then here in this case also it will be reflected just below. So here I is equal to I. So these are the three rules. What is the fourth rule then? So fourth rule, student, fourth rule is what? Now here we have four rules of ray diagram. So again I take one concave mirror. Okay, I take one concave mirror. Now fourth rule, so here P, F and C. Right. So here, if a ray of light is incident such that it passes through the center of curvature, then it traces its own path. So here angle I is equal to angle R and that is equal to 0. So in this case also, if I take one convex mirror, then what will happen? If the ray of light is incident such that it appears to pass through the center of curvature. So this is the pole, this is F, this is at equal distance C. So if it appears that it is incident at the center of curvature, then it also traces its own path. So these are the four rules of ray diagram for spherical mirrors. Now let's see the image formed by these spherical mirrors when the object is placed in front of them. So we will discuss image formation by convex mirror and concave mirror in our next lecture. Thank you for watching Saptarshi Mindware EdTech videos. Keep watching. Thank you very much.